going to be talking about the crystalline allotropes of carbon. Okay, when we hear the word crystalline allotrope of carbon in chemistry, what comes to our mind? It is the pure form of carbon. So now we talked about the amorphous, which is the impure form in our last video. So okay, we have two types of crystalline allotropes of carbon, which are graphite and diamond. So now, first of all, we're going to start with graphite. Okay, graphite is the most stable allotrope of carbon, and also graphite exists naturally as a dark black opaque solid called Bloom-Barlow. Note that is actually a UTM equation. Okay, so now graphite has some properties which makes up the uses, which we are going to be discussing now. First of all, graphite exists as a two-dimensional sp3 hybridized sheet of carbon, which gives it the ability to be able to slide, which is why it is used as a lubricant. Okay, note that graphite exists as a two-dimensional sp2 hybridized sheets of carbon atom. Okay, this statement said now, it can also, like when you see that graphite exists as a planar molecular structure, it also means what this is also what we are trying to see. Let me just write it down in case. Planar molecular structure. Okay, due to this ability for graphite to exist in a two-dimensional sp2 hybridized sheet of carbon atom, it now has some properties based on this ability. So these properties are now the uses of graphite. The first property is that as a good lubricant. Due to the sliding effect of the two layers of carbon, because like it's in set of pairs, like two, so which makes the structure, lattice structure, to be able to slide over. That is why it's used. That is why it could be used as a lubricant. And also note this: graphite can be used in pencil, as lead is used for making pencil. Though graphite has to be mixed with clay to be able to be used as pencil. Just note that it's also a UTM equation. And finally, as a good conductor of electricity. This is due to the free mobile electrons in graphite. It's not like diamond. Diamond is so tied up, there is no free electron. But in graphite, we have free electrons which can be able to carry current, That is why it's a good conductor of electricity. So now, this graphite can be used as an electrode in a dry cell, and also can be used as in a nuclear pile. Okay, next up we are going to be talking about diamond. Okay, diamond is the last crystalline allotrope of carbon. So now we have to understand this. Diamond is actually close to graphite, but there is a difference. Now, first of all, I want you to notice diamond is the purest form of crystalline carbon, and also amorphous. So just note it is the purest form of carbon. So now we talked about how graphite exists as a two-dimensional sheet of carbon, which is why it's called planar molecular structure. But this diamond here has a slight difference. Okay, now based on the structure of diamond, each carbon atoms are tetrahedrally linked by 4 other carbon. What do we mean by tetrahedrally? Tetrahedral means that it's actually like also like 4. Tetrahedral shape is like 4. So something like this. This is what we mean by tetrahedral. I don't know if you are familiar with something like this. Okay. This is the structure of methane actually. This is what we mean by tetrahedral. So now, if they say each carbon atom are tetrahedrally linked with 4 other carbon, what do we mean? We mean that if you remove this H, each carbon is tetrahedrally linked with other 4 carbon. Do we get it now? So due to the linkage, it now brought to a 3-dimensional sp3 hybridized giant molecule. Okay, now you will now want to ask me what is sp3. First of all, a single bond is sp3. So now, do you understand everything now? I try to break it down to the list. Now, due to this structure, diamond now has a shape called octahedral. So the shape of diamond is what? Octahedral. I think that is very popular. Almost everybody knows it. Okay. Now moving forward, based on this structure, diamond now has properties which I also uses. First of all, the abrasive property. The abrasive property. This means that diamond is the strongest and hardest natural substance. Note, natural substance. Okay, so diamond is the strongest natural substance that exists. So due to this hardness, diamond is used for cutting metals, cutting other strong stuffs which technically other substance like iron can't do. So next okay, what I mean by lustrous, we mean it's shiny. So diamond can be used, or apart from this word lustrous, you can also say refractive index. So due to its refractive index, diamond now has a lustrous, which means it can reflect light and is very shiny. So due to this property, diamond is now used as jewelries and used to make some fancy stuff. So take note of that. Okay, as we were saying that diamond is the hardest natural substance, and also we also have a synthetic strongest substance. Actually, I think diamond is the second to it, but that one is synthetic and diamond is natural. So it's called boron nitride, is the strongest synthetic substance. So just note that in case it will come handy later on. Okay, now we're going to talking about isotopes of carbon. We have 3 isotopes of carbon. First, we have carbon 12, which is like the most abundant of them all, like the most conversant. Followed by we have carbon 13. This carbon 13 appears in little quantity. These two are the natural isotopes of carbon. So, but this final one actually cannot occur naturally, and apart from that, it can occur naturally. It's also radioactive. Carbon 14. This carbon 14 is a UTM equation. Note it. It's used in carbon dating. What do you mean by carbon dating? Dating of fossils and rocks, like checking of the age of rocks or the age of animal remains and all that is the work of carbon 14. Take note of this. So that is all about the isotopes of carbon. Just note it. This is the most abundant, this is the least abundant, and finally this is the radioactive synthetic isotope of carbon. So moving on to the like the compounds of carbon, which are CO and CO2. We have two oxides of carbon. We have two oxides of carbon, which are CO, which we can also call carbon monoxide, and we have CO2 called carbon dioxide. Okay, this actually confuses people a lot. Carbon monoxide is also called carbon 2 oxide. Take note of this. Carbon monoxide is also carbon 2 oxide. Actually, thinking of it, it actually feels as if carbon dioxide should be carbon 2 oxide, but it's not so. That is why it's called chemistry. Okay, moving on. This other one, carbon dioxide, which is CO2, is also called carbon what? Carbon 4 oxide. Okay, now another thing to note about this oxide, this first one, carbon monoxide, is a neutral oxide. Take note of that. It's colorless, odorless, tasteless too, and is neutral. So little more you can't check it. So it's a neutral oxide. Then finally, CO2, called carbon dioxide, is the acidic oxide of carbon. You get what we mean by acidic? When this CO2 reacts with water, it will form an acid. So now this carbon 2 oxide is also odorless, and you can actually see it. So that's what I'm saying. So, but the only difference is that this is acidic and this is neutral. Note, I didn't say basic, I said neutral. Okay, talking on carbon 2 oxide, also known as carbon monoxide. Now, first of all, if we are going to study this as a subject, now first thing you have to know about carbon monoxide is that it is formed from the incomplete combustion of carbon. Note this, incomplete combustion of carbon. So if it's complete, if it undergoes complete combustion, it's actually going to form an atom, which we will be talking about. But first of all, let's focus on carbon 2 oxide, incomplete combustion. And what we mean by incomplete combustion of carbon, we mean that there is a limited supply of air during the combustion of carbon, or carbon compounds. So now, moving forward, just note that down. Now, carbon, now let me write the formula. When carbon reacts with oxygen molecule, it will give us what? CO, 2 molecules of CO. This is the reaction, just take note of it. Okay, now moving forward, this carbon 2-oxide, just note it, carbon 2-oxide can also be formed from the dehydration of folic acid, known as methanoic acid. Folic acid, also known as methanoic acid, or oxalic acid, also known as ethane dioic acid. This dehydration is due to what? This dehydration is due to H2SO4, hydrogen sulfide. So the dehydration of folic acid or oxalic acid by H2SO4. Note that. That is how we can get carbon 2-oxide from this. Alright, so moving forward, okay, reactions of carbon 2-oxide. This carbon 2-oxide we've been talking about, it's one, acts as ligands on transition metals. Transition elements. Okay, what are we talking about when we mean CO act as ligands on transition elements? We mean that CO reacts with hemoglobin to form an irreversible reaction. We know that hemoglobin in our blood carries oxygen, but the reaction of oxygen and hemoglobin is reversible. But when we are exposed to CO, it forms a permanent reaction, which means we cannot remove CO from our body once it has entered our body. So now look at the reaction. CO react with hemoglobin to give an irreversible reaction. So just note this. Actually, this is more biology than chemistry. So note it. It's an irreversible reaction. So this carbon 2-oxide keeps accumulating. The more it's entering your body, it keeps accumulating, and it will stop the intake of oxygen. Like the more you are taking in CO, you will reduce your chances of getting more oxygen in your body. Take note of that. So moving on, CO acts as a good reducing agent. Alright. Okay, finally, CO, that is carbon monoxide, acts as a good reducing agent. How do I mean? An iron oxide react with CO. To give us the ion and displace CO2. So now from the look of things, this equation is not yet balanced, but let's balance it. Okay. Okay, that's good. The reaction is balanced. Okay, talking about carbon dioxide, also known as carbon dioxide, there are things we have to note. But first of all, let's know how this carbon dioxide is being formed. Okay, carbon dioxide is formed from the complete complete combustion of carbon and carbon compounds. What do we mean by complete combustion? When there is excess air present or unlimited air present in the combustion process. So when the carbon combusts with enough air present, it will give us carbon dioxide. But when it's incomplete, I was saying it now minutes ago, when there is incomplete combustion, the product that will be liberated or displaced is CO. So now moving forward, we talked that carbon dioxide is the acidic oxide of carbon, and also this gas is odorless, colorless, but has a refreshing taste. Note that this refreshing taste makes carbon dioxide used as carbonating drinks. It's making use for carbonating drinks. That is this carbon dioxide, because of that refreshing taste, that property has. That is why it's used for carbonating drinks. Okay, so next up, carbon dioxide can be used to extinguish a burning flame, which is why it is used as fire extinguisher. Note that. And also, carbon dioxide, when it come in contact with lime water, form a milkish or perhaps cloudy pipetting. So just know that precipitate. So, and also this is also an important point to note about CO2. CO2 in air has an approximate percentage of 0.03% in air, as we have oxygen to be 21% and other elements too in air. So just note this viewpoint. And now the reaction that gives us carbon dioxide is when carbon reacts with oxygen molecule, it will give us CO2. Okay, next up will be the reactions of carbon dioxide.